my name's Tan and welcome to the channel. Today we'll be talking about coding. Coding is one of the most in-demand skills to have in this generation. It's integrated into everyone's life, from the phone in your pocket to the planes that carry you across the world. With many jobs emerging from the tech industry, it's essential to have this skill. You're starting right here with our first major series, The Fundamental of Coding. We'll be building your knowledge from the ground up. But what actually is coding? It all boils down to one simple idea. In the next few minutes, we're going to break down the core concept that every program, from a TikTok filter to AI, follows. Forget computers for a second. Let's break down the most terrifying piece of tech the world has ever created. The toaster. Although it has one purpose, it perfectly illustrates the job of a program. What is the purpose? You put in cold bread and you turn a dial. The toaster follows a fixed set of instructions. If the dial is set to 3, then energize the coils for 9 seconds. This is the process, the instruction inside the machine. And what do you get out? Hot golden brown toast. That's the output. As you can see, all programs are just simple sets of instructions. Whilst we as humans understand English, a computer needs its own language to follow these steps. Later in the video, we'll write a simple program to add 2 numbers. The structure will be exactly the same, but we'll be using Python. I've chosen Python for these tutorials, and here's why. Firstly, Python is a beginner-friendly language. Its simple, English-like syntax gets you writing code much faster than any other language out there. Secondly, Python opens doors to high-paying jobs in tech. Think AI, machine learning, and data science. Thirdly, it's incredibly versatile. You can build from web apps to powerful automation scripts, meaning your skills will always be in demand. Plus, Python has a massive community, giving you access to a huge library of ready-to-use tools, making complex projects a breeze. Okay, hopefully I've convinced you to use Python. Let's download it. If you go to the link above, you will go to the download page on the official Python website. Just download the correct version for your laptop or desktop. So if you're using Windows or Mac OS or Linux, make sure you're downloading it for the right operating system. So usually the stable version, the one that I'm using, is 3.10, but you can also download 3.12. It doesn't really matter too much, just make sure that you're downloading a stable version. Okay, hopefully you've downloaded Python correctly on your systems. On Windows, if you just type in IDLE, you should see here Python show up. So if you click on that, it should take you to this page here. That's perfectly fine. That is good. Don't worry about these random bits of text. This is basically the tab that allows us to interact with the computer. So what I want you to do, first things first, simply click the file button here and start a new file. That should take you to a page like this. Don't worry just yet about this code. What I want you to do is simply save your empty page into a secure folder that you'll remember. Maybe call your folder Fundamentals of Coding and save your code using an appropriate title. Once you've done that, we can get started on the code. Now, let's take the input process output cycle and apply it to our first code. We're going to write a tiny piece of code that simply adds 2 numbers together. The very first thing that we need to do is the input. The computer doesn't know which numbers to add unless we ask the user. To do that, we need to use a command like input. Now on the screen you can see that we've got 2 lines of code. They're pretty much the same. The only difference is the first one says first, the second one says second. We ask the user for the first number and we immediately store it and label it as number 1. The same occurs with the second one. The use of input here is that it allows the computer to interact with the user, and you'll see it in a second. So this very sentence that's in these speech marks will pop up. So here 7, 9, and the code stops. Now you're probably looking at the code and you're like, well, the code is already finished here. Why is it not working? That's because these little hashtags here have made the line red, which means it ignores the code. So for now, the computer can only see these 2 lines of code. It doesn't actually take in these other 2 as they're commented out. That being said, the input stage is technically complete. We've successfully collected 2 pieces of raw data. Let's move on to the process stage. This is a stage where the computer's central processing unit manipulates or transforms the input data according to a set of coded instructions. In a computer program, this involves calculations, comparisons, sorting, conditional checks, or applying a formula to the input. So if you go back to our toaster analogy, the coils heating up and applying a fixed amount of energy for 90 seconds was our process. In our case, we need to add 2 numbers together. So as you can see, the entire third line is our process. We take number 1 and number 2 and we run an additional operation to the numbers, and we label this as result. So you can see that we've got this random command in front of our numbers and we've put numbers in bracket. Now what this is doing is taking the input from the users and turning them into a integer. Now, what does integer mean? An integer is a whole number, not a fraction or decimal, that can be either positive, negative, or 0. It comes from the Latin word integer, which means whole. So with that in mind, let's run our code and test it out. So if you focus on this little section here for now, if you put 6 and 2, the code stops there, which means it functions. So now let's look at other cases here. So I tested out 1.0, 2.0, and the code actually ran into an error, which shows that our process is working. How is it showing that? Because it's not taking in a number that is not an integer. So this would be classified as a float. Again, we tested the code using a symbol and a letter. So a character and a symbol. And the code again did not like this answer. As you can see here, again, it's saying it's a value error. So this is showing that our process is working. Okay, now let's get on to the final stage, which is the output. This is a stage where the system presents the final result of the process back to the user or to another system. Now, in a computer program, this could be displayed as a result on the screen, or you could be saving it into a file, or sending a message, or moving a robotic arm. But if we go back to our toast analogy, this was the final product, so it was the hot golden brown toast. So in our case, we will use the print command to display the answer stored in our result label. This completes our cycle. The users provided the input, the program executes the process, and we see the final desired output. So let's test this out. So you can see here, we've got the print function, and anything inside this bracket is basically outputted on the screen, like we saw before with this one here. However, you can see that we've got a string, so this would be classified as a string, which is basically a bunch of characters or symbols or numbers within a speech mark. So you can see that it says the total is colon and then a little space, and then we've got a comma here to separate the fact that we want to output this label result. Because if we actually try this out instead, let's say we kept it like that and we put the speech mark at the end, what do you think will happen? Let's test it out. So 6, 2 should be 8, right? As you can see here, it's just printed out the total is colon, space, comma, result. But we don't want that. We actually want the result, right? So now, let's try it with the speech mark here and the comma separating the fact that result is labeled here. So let's run the code again. 6, 2. And as you can see here, the code now understands that we're referring to this label here. And you can see here it's printed our result. So there you go. That's your first piece of code that you've written. If you've done other coding before, that's fine. But for some this will be their first code, and that's brilliant. I want you guys to try and mess around with this code now. As I talked before about floats, you can change these to anything you want. You can change this to minus, you can change it around. I want you guys to mess around, break the code, and you'll learn from this. This is one of the key facts to coding. You need to be able to break code. So I'll just give you an example. What happens if we put int in front of input? Let's try this out. So because you can see there, number 1 is expecting an integer immediately. If we put something like a here, the code breaks immediately. Whereas before, it would actually take in a as an answer. So you can see here, it took in a sign and it didn't say anything. So that actually makes the code more efficient. Have a go, mess around with the code, and if you need anything, drop it in the comments. I'll try and answer any of your questions. Our program worked correctly, it functioned, it went through the whole cycle, but it was easily broken if the user put in a symbol or if they put in a float. But why? Shouldn't the code just be able to handle that? So in a real world program, we can't just run in straight lines of code. We need to be able to make decisions and repeat tasks based on what the user does. This ability is called control flow, and that's the focus of our next video. Next time we'll tackle sequence, the most fundamental part of flow. We'll learn why the order of your instructions matter more than anything else. So if you want to master the fundamentals, hit the subscribe button, ring the bell, and I'll see you in the next one.